Hello friends, last time we have started the chapter of differentiation in the paper of differential calculus. We have defined derivative of a function and we have defined right hand derivative and left hand derivative, and the derivative of a function exists if the right hand derivative is equal to left hand derivative, that we have seen. And also we have seen that differentiability implies continuity, but the converse is not true. That means continuity does not imply differentiability. A continuous function may not be differentiable. That example we have seen last time. Now we shall consider the next example to examine differentiability, and also we will examine the continuity. For that purpose, I have written a problem here. Examine the function f where fx is equal to x into bracket e raised to minus 1 by x minus e raised to 1 by x divided by e raised to minus 1 by x plus e raised to 1 by x. X is not equal to 0 and this is equal to 0 when x is equal to 0. As regards continuity and derivability at the origin, means we have to examine this function for both continuity as well as derivative at the origin. At the origin means x is equal to 0. So that is to be examined. But for that purpose, we shall consider a note, and then we will consider the solution of this problem. So for a note, I shall write here. We will see some limits. First we shall consider limit x tends to 0 from right of 1 by x. So what will be this limit? As x tends to 0 means x becomes nearer and nearer to 0, what will be 1 upon x. Now this can be checked by taking the values of x closer to 0. For example, if I consider x and then I shall consider the value of 1 by x. So from positive means values, x lies on the right side of 0, means 0 is here, x is on the right side of 0, and close to 0, so we may consider say 0.1 and then 0.01 etc. So I shall consider 0.1. So what is 1 by x? 1 divided by 0.1, or that is 10. So 1 by x is 10, and again till closer 0.1. So 1 by x will be 1 upon 0.01, and that is 1 by 1 upon 100, or which is equal to 100. Reciprocal is the number 100, and therefore this is 100, and that means x is approaching towards closer and closer to 0. So this is more closer than this number. Again, if we consider 0.001, then it will be 1000. And as you see, this approaches to 0, this becomes bigger and bigger, means it becomes infinity, or it tends to infinity, and thus limit of 1 by x as x tends to 0 from right is infinity, positive infinity. Now second thing we shall consider as limit x tends to 0 from left of 1 by x. Now what is the change here is x is on the left side of 0. 0 is here, x is on the left side of 0 means x is less than 0, and x is less than 0 means x is negative, and but close to 0, and that number will be say 0 minus 0.1 minus 0.001. Only there will be negative sign, and we will consider negative of this, negative of these numbers, and this will be negative again. Reciprocal will be negative. That is the change, and this is minus 1000 and so on. So therefore, as x tends to 0 from left, this becomes bigger and bigger with negative sign, and that means it will tend to minus infinity. So therefore, this limit is minus infinity. You note this. That is the difference. When x tends to 0 from right, it becomes plus infinity. The limit of 1 by x is plus infinity, and when x tends to 0 from left, because these are negative values and it becomes larger with negative sign, and therefore it tends to minus infinity. And thus we have limit of 1 by x. So, but limit x tends to 0 of 1 by x, this will not exist. This does not exist. Why? Because the right hand limit is infinity, the left hand limit is minus infinity, and these are unequal. And when the left hand limit and right hand limit are unequal, the limit does not exist. So this does not exist. But this exists. The right hand limit exists, it is infinity. The left hand limit exists and it is minus infinity. Why we are writing this? Because these terms are appearing in the function 1 by x, and we want to take the limit as x tends to 0. So therefore we have written, and thus this is to be remembered, that limit 1 by x as x tends to 0 from right is infinity, and second result we have written limit x tends to 0 from left of 1 by x is minus infinity. And one more thing we shall consider is third, as limit x tends to 0 of from right of e to the power minus 1 by x. Now what will be this? E is the base of natural logarithm and it is a fixed number, and therefore the limit is for x, and we have to take the limit at the exponent 1 by x here, and therefore this e and negative sign remains as it is, e raised to minus, and limit will be here, limit x tends to 0 from right of 1 by x. And now you see, we have taken this limit at this term 1 by x, because limit is for x, others minus and e remains constant, fixed. And what is this limit? We have here, it is infinity, but there is negative sign, so it is e raised to minus infinity, and e raised to minus infinity means 1 upon e raised to infinity, and as e is a number between 2 and 3, and that is raised to infinity means it becomes infinity, and when the denominator is infinity, the value tends to 0. So therefore, because we have 1 upon 100 is 0.01, 1 upon 1000, it becomes less and less, and therefore if the denominator becomes bigger and bigger, the value tends to 0, and thus and vice versa, if the denominator becomes less and less, the value becomes bigger and bigger. So therefore this tends to 0, or this limit is 0. And one more we shall consider, limit x tends to 0 from left of e raised to 1 by x we shall consider, and this will be e to the power limit x tends to 0 from left of 1 by x, limit of this. And what is the limit of 1 by x as x tends to 0 from left? It is minus infinity. So therefore this is e raised to minus infinity, and this is 1 upon e raised to infinity, and this is equal to 0. So these are the limits we require here, because the function contains these terms, e raised to minus 1 by x and e raised to 1 by x. So that's why we have written this as a note. Now we shall consider the solution for this problem. We remember this as limit 1 by x when x tends to 0 from right is infinity, limit 1 by x when x tends to 0 from left, it is minus infinity. And this is also to be remembered, e raised to minus infinity is 0, 1 upon e raised to infinity, 1 upon a very large number, and that is 10, actually it tends to 0. So instead of equal to 0, we may write tends to 0. But limit of this is 0, limit of this term is also 0, and that is to be remembered. Now we consider the solution of the problem. So solution. First we shall check the continuity at point 0. at the origin means x is equal to 0. Continuity at x is equal to 0. And for checking continuity at x is equal to 0, we have to take the left hand limit and right hand limit, because 1 by x, its limit as x tends to 0 from right is different, and x tends to 0 from left is different. It is entirely different. One is plus infinity, another is minus infinity. So therefore we have to take both the limits, and thus we shall consider limit x tends to 0 from right of fx, and that is limit x tends to 0 from right of fx. Fx is this function x e raised to 1 by x, or it is minus 1 by x minus e raised to 1 by x divided by e raised to minus 1 by x plus e raised to 1 by x. Now what is to be done? See, we may see limit x tends to 0 from right of 1 by x is infinity, and so we have here e raised to infinity will be infinity. We don't want this term, but we should consider this as limit e raised to minus infinity. We know e raised to minus infinity is 0, and therefore we keep this term minus 1 by x, and we eliminate this term e raised to 1 by x, because e raised to minus infinity, we have e raised to minus infinity tends to 0, and therefore this term this is becoming infinity, and it becomes e raised to minus infinity. So we keep this term. We don't want this term because it becomes e raised to infinity, and e raised to infinity will tend to infinity. So we don't want this term, and therefore we eliminate this. And to eliminate this, we divide by this term e raised to 1 by x at numerator and at the denominator. So the value should not be changed. So we have to divide both numerator and denominator by e raised to 1 by x, or in other words, divide by e raised to 1 by x means multiply by e raised to negative power minus 1 by x, and what this term will be. So we may write here multiplying numerator and denominator by e raised to minus 1 by x on RHS. So we get limit x tends to 0 from right of fx is equal to limit x tends to 0 from right of x will remain the same. We divide these each term by multiply e raised to minus x. So e raised to minus x into e raised to minus 1 by x. Use the laws of indices. There will be addition of these two indices, and minus 1 by x minus 1 by x, that is minus 2 by x. So it is e raised to minus 2 by x minus, and what is the multiplication of these two? E raised to 1 by x into e raised to 1 by x. E raised to 1 by x minus 1 by x, that is e raised to 0. Addition of indices, and e raised to 0 is 1. So therefore it is 1. We are dividing by this term, so e raised to 1 by x divided by e raised to 1 by x is again 1. Or that means we are multiplying by e raised to minus 1 by x, and this is divided by same at the denominator. The same terms are there, only there is plus sign in between two terms, and therefore this becomes e raised to minus 2 by x plus 1. So this we have obtained. You note this step why we have done like this. And now further, this is equal to limit from right hand limit x tends to 0, and you see what is this limit, e raised to minus 2 by x, and this e raised to 1 by x limit as is infinity. Limit x tends to 0 from right of 1 by x, that becomes infinity, and 2 into infinity is again infinity. So therefore this is e raised to minus infinity, and this is x tends to 0, this becomes 0. 0 into e raised to minus infinity minus 1 divided by again the same. So this is equal to limit of x, or limit x tends to 0 from right of fx, and that is equal to limit of x as x tends to 0 is 0. So this 0 into bracket e raised to minus infinity minus 1 divided by, you remember 2 into infinity is again infinity, and here also it is the same term, so e raised to minus infinity plus 1. Now we have here e raised to minus infinity tends to 0, and therefore this is 0. 0 minus 1 divided by 0 plus 1, or but this term is 0, or which is 0 into minus 1, or you see this 0 minus 1 divided by 0 plus 1, since e raised to minus infinity is 0, and here we have used, since limit x tends to 0 from right of 1 by x is infinity, so therefore we are writing this as infinity, and 2 into infinity is again infinity, and thus this is 0 into minus 1, that is 0. Left hand, right hand limit is 0. Now we shall find out the left hand limit. Next, to find out the left hand limit, we consider this as limit x tends to 0 from left of fx. Limit x tends to 0 from left. Now, if you consider the limit x tends to 0 from left, now 1 by x tends to minus infinity. Limit of 1 by x, positive 1 by x, is minus infinity. So we want e to the power minus infinity, and that is the required term, e raised to, now you see, this will be the required term, e raised to, and this becomes minus infinity. 1 by x limit is minus infinity. So this term we shall keep, and we don't want this term. Means divide by this term. Divide by e raised to minus 1 by x means multiply by its reciprocal, e raised to 1 by x. So instead of multiplying the numerator and denominator by e raised to minus 1 by x, now multiply numerator and denominator by e raised to 1 by x on RHS, and this becomes limit x tends to 0 from left, limit x tends to 0 from left. And now what happens to this term? So this becomes 1, e raised to 0, this is now 1 now. And what about the next term? It is e raised to 1 by x into e raised to 1 by x, addition of indices, that is 2 by x, e raised to 2 by x. So it is 1 minus e raised to 2 by x divided by, similarly the denominator having the same term, 1 plus e raised to 2 by x. So this is to be the step to be noted. And now you see limit of this, that is 0. Limit x tends to 0 from left or right, that is limit of x will be again 0. It is 1. The first term is fixed, that is 1, constant, minus. Now e raised to, this is 1 by x, or 2 into 1 by x. And but what is the limit of 1 by x? As x tends to 0 from left, it is minus infinity. So this is 2 into minus infinity, but 2 into minus infinity is again minus infinity. So therefore this becomes e raised to minus infinity, and that is e raised to minus infinity. And similarly the denominator is 1 plus e raised to minus infinity. You note the changes. So this is the left hand limit, and here x tends to 0 from left, the limit of 1 by x is minus infinity. So therefore we have written e raised to minus infinity here, and the denominator also. Now what is this? 0, limit of x separate, using the theorem on limit, limit of x separate, limit of remaining term separate, that is 0, and it is 1 minus 0. This is 0, and this is 1 plus 0. So thus this is the left hand limit, but earlier we have the right hand limit is also 0. and this is limit x tends to 0 from left of fx is equal to 0, and we have both the limits are equal to 0, and that is further we want the value of f of 0. For continuity all the three must be the same. Now what is f of 0? It is given. So see the example. Given f of 0, when x is 0, fx is 0 means f of 0, put x is 0 here, f of 0 is equal to 0, that is given f of 0 is equal to 0, and thus we have the right hand limit we have obtained are also 0, the left hand limit is 0, and the value is also 0. So therefore we have limit x tends to 0 from right of fx is equal to limit x tends to 0 from left of fx is equal to f of 0, and all are equal to 0. And when we know the definition of continuity, when the limit is equal to the value of the function, then the function is continuous. Here the left hand limit, right hand limit, and the value of the function at 0 all are equal, and therefore fx is continuous. Fx is continuous at x is equal to 0. So this proves the first part of continuity. Now what remains to prove check is the differentiability. So we have obtained the function, this function is continuous at x is equal to 0. The first part is over. Now we check the differentiability, derivability at x is equal to 0. Second thing, differentiability or derivability at x is equal to 0. Same procedure we shall have to consider right hand derivative, left hand derivative at 0. And we have defined last time what is right hand derivative and left hand derivative. So first we shall consider r f dash 0, right hand derivative of f at 0, and the definition is limit x tends to 0, point 0, fx 0 from right, fx minus f0 divided by x minus 0. R f dash c we have defined limit x tends to c, fx minus fc divided by x minus c. C here is 0, and therefore this is the definition for right hand derivative at 0, and that is limit x tends to 0 from right, fx minus f0. What is f of 0? It is 0, and this is x minus 0 is x. So therefore this is x fx divided by x only, since f0 is 0 given. So this value is given, f of 0 is 0. And thus this is limit x tends to 0 from right, fx divided by x, and that is limit x tends to 0 from right. Now it becomes simpler than the earlier case. Fx we have to divide by x. See, this is fx, and we have to divide by x means this x cancels, and only these two terms remains, and therefore this is e raised to minus 1 by x minus e raised to 1 by x divided by e raised to minus 1 by x plus of e raised to 1 by x. So that is remaining. And now as in earlier case, we shall now write the limit directly. Here this is equal to, but before that what we have to do is limit x tends to 0 from right. We have to divide by which term? You see, this limit 1 by x from right is infinity, so this becomes e raised to minus infinity. We keep this term and we don't want this term. So as earlier, multiply by e raised to minus 1 by x to the numerator and denominator. So we write here multiply numerator and denominator by e raised to minus 1 by x on RHS. And thus what we get is r f dash of 0 is equal to limit x tends to 0 from right. Now if you multiply by e raised to minus 1 by x, this term will be 1 and this will be e raised to minus 2 by x. Same steps we are there, only x is absent here because we have divided by x. Minus, that is 1, we check it, and divided by e raised to minus 2 by x plus 1, and this is equal to e raised to minus infinity because this is 1 by x, limit x tends to 0 from right is infinity, and minus is there, so 2 infinity is again infinity, and therefore e raised to minus infinity minus 1 divided by e raised to minus infinity plus 1, and thus this e raised to minus infinity is 0, 0 minus 1 divided by 0 plus 1, and that is minus 1 divided by 1, which is equal to minus 1, and that we have obtained r f dash at 0 is equal to minus 1. Now what remains is L f dash 0, left hand derivative, and that is only the change is x tends to 0 from left, and that is x tends to 0 from left. It is the same definition, only the limit approach is changed for left hand derivative, and this is again limit x tends to 0 from left, e raised to minus 1 by x, etc. Now here what we have to do is multiply the numerator and denominator by e raised to plus 1 by x. We have to consider this limit. 1 by x is minus infinity, so we keep this and we eliminate this, means we have divided by e raised to minus 1 by x, means multiply by e raised to plus 1 by x, and what is the left hand derivative will be limit x tends to 0 from left, or yes, we have considered multiplication by e raised to 1 by x, it is 1. Now that will be 1 minus e raised to 2 by x divided by 1 plus e raised to 2 by x. Laws of indices we have to use. You should verify yourself these steps, how we have multiplied and why we have multiplied, because we want to use these results. And now this is minus infinity, limit x tends to 0 from left, 1 by x is minus infinity, and therefore 2 into minus infinity is minus 2 infinity, that is again minus infinity. So and that becomes, so this is equal to 1 minus e raised to minus infinity divided by 1 plus e raised to minus infinity, and you see this is 0, 1 minus 0 divided by 1 plus 0, and finally this is left hand derivative. Left hand derivative at 0 is equal to 1 plus 1, this is 1. Now we observe what is the right hand derivative of f at 0, it is minus 1, and the left hand derivative of f at 0 is 1. So these are unequal, and therefore the function is not differentiable at x is equal to 0. So thus we have these are unequal, that is left hand derivative is equal to, or we see that L r f dash 0 means right hand derivative is not equal to left hand derivative of f at 0, and therefore fx is not differentiable at x is equal to 0. So thus the function is continuous at x is equal to 0 but not differentiable at x is equal to 0. So thus fx is continuous from first part, continuous at x is equal to 0, but fx is not continuous at x is equal to not differentiable. Fx is not differentiable or derivable at x is equal to 0. So derivable at x is equal to 0. It is not differentiable or derivable. So this is the examination of this function as regards to both continuity and differentiability. So in this way we can examine a given function for continuity and for differentiability. For both to check the continuity we have to find the left hand limit and the right hand limit, and to check the differentiability we have to find the right hand derivative and left hand derivative. If these are equal, then the function will be differentiable, otherwise not, like this. So thus in this way we can examine given function for continuity and differentiability. Now we shall consider the geometrical interpretation of derivative. Geometrical interpretation of derivative, and that means what is the meaning of derivative, geometrical meaning of derivative. And you have studied this last year also and used this result, but we will see it again. Geometrical interpretation of derivative or geometrical meaning of derivative. Now we state as a theorem the derivative of a function we shall consider fx, derivative of a function fx at point x is equal to c, or that is f dash represents or is the slope of the tangent to the curve y is equal to fx at point, and we may say the point suppose the point is p, c, f of c. This is the geometrical interpretation or meaning of derivative. What derivative represents? Derivative represents, or derivative is equal to the slope of the tangent to the curve y is equal to fx at point p, c, f dash, c, f of c is the point. And simply derivative represents slope of tangent at the point, and we shall prove this result. And to prove this result we draw a figure. That means we shall consider a curve y is equal to fx. Suppose this is the curve, and suppose this point is p, and we will consider the curve shaped like this. Let this point be p and this point be q. So we have to consider the chord pq and draw a tangent at p also. This is the tangent line at p, and suppose the origin we will consider here. So this is y-axis, and suppose this is x-axis. This will be y and x-axis. And now you see this is the point P we have, and here this is the point Q. These are the 2 points. We draw perpendicular from P on the x-axis. Let it be PL, and let this be QPR. This point is R, and let this point be P. Further, draw perpendicular from Q on x-axis. Let it be QM, and again we draw perpendicular from P on this, and let it be PM. So these are the points we have considered. Consider the curve. The curve is y is equal to fx. This curve. Consider curve y is equal to fx. Take 2 points P and Q on the curve. Two points as P, C. If the x coordinate of P is C, what will be its y coordinate? Y coordinate will be f of C, because the curve is y is equal to f of x. If x coordinate is a, y coordinate will be f of a, and therefore the coordinates of P will be C, comma f of C. And Q. Now we consider the x coordinate of Q as C plus H. What will be its y coordinate? Its y coordinate will be by this. Y is equal to f of x. That means f of x coordinate, f of C plus H. So this is f of C plus H. And the coordinates of P we have written C, f of C. Now what will be the length Pm that we shall write? Draw PL ordinates we have shown in the figure. We have drawn perpendicular from P and Q on x-axis. So draw PL, QM ordinates on x-axis. Or perpendicular on x-axis, that you can say. Draw PL, QM perpendicular on x-axis. Further, draw PN perpendicular. PN is perpendicular to QM. Now, what is PN? PN is same as LM. This is right angle. These are also right angle. And therefore, these sides are the same. PN is equal to LM. But what is LM? LM will be, this is on x-axis. And what is OL? OL will be x coordinate of P, that is C. And what is OM? OM will be y coordinate of Q, that is C plus H. So therefore, LM will be C plus H minus C. Definition of x coordinates. And thus, this is the C plus H minus C means H. So this distance is H, because x coordinate of P is C and x coordinate of Q is C plus H. The difference of C and C plus H is H. That we have written. Further, what is this Qn we want to write, or NQ? NQ is equal to, NQ is MQ minus NQ. MQ whole length minus MN. You see, MQ, this length is MQ minus this length, MN. And again, this will be MQ. MQ means total length from this. That is y coordinate of Q. That is f of C plus H. Or what is MN? MN is same as LP. So that is MQ minus LP. And but you see, what is MQ? MQ is y coordinate of Q, that is f of C plus H. And minus LP, LP is y coordinate of P. And what is y coordinate of P? F of C. So therefore, this is f of C. Thus we have this NQ. Now what we shall consider is the angle XRQ is same as the angle NPQ, because these are the corresponding angles here. These two lines are parallel, and therefore this angle is equal to this one, and that is now tan of next tan of angle XRQ is equal to tangent of angle NPQ. These two angles are the same. So these two are parallel lines, and if you consider this, then the angle, this angle and these two angles are equal corresponding angles by transversal line, and therefore tangent of NPQ. And but what is this? This will be a slope of chord PQ, because tangent of the inclination of the line is the slope, and that is slope of chord PQ is equal to slope of chord PQ. And what is the slope of chord PQ? And that is tan, or we can first consider slope of chord PQ is tangent of angle XRQ is equal to tangent of angle NPQ, and that is equal to, now this is tangent of NPQ, tangent of NPQ, or I shall write here first slope of chord PQ, and that is equal to slope of chord PQ is equal to inclination of this line, tangent of XRQ, and which is same as tangent of angle NPQ. And what is the tangent of angle NPQ? Tangent of angle NPQ, tangent of this right angle triangle, that is opposite side divided by adjacent side, tangent ratio. So it is NQ divided by PN, or NP, we have written PN. And the slope of chord PQ is equal to NQ. What is NQ? You see, it is NQ is f of c plus h, f of c plus h minus f of c, and divided by what is Pn is h. Now we suppose this as 1. So thus what we have obtained is slope of PQ chord. Slope of PQ is NQ divided by Pn, and that is f of c plus h minus fc divided by h. But we want the slope of tangent. Now this chord PQ becomes tangent at P. Tangent at P when this point Q tends to P along the curve. You see, as Q approaches P along the curve, this chord turns and it becomes tangent at P. So when Q becomes closer and closer to P, the chord will turn like this and it becomes tangent. Tangent line is the line which touches the curve at single point, and therefore this Q is very close to P. We consider it as the single point, and the chord turns like this, it becomes tangent. So that we have to write. Now as Q tends to P along the curve, so we have written this slope of chord PQ. Now as Q tends to P along the curve, the chord PQ becomes tangent PT. So this is the meaning. Chord PQ or QP becomes tangent PT. The line turns and it becomes tangent PT. Also, as Q tends to P, means the coordinate of Q, x coordinate of Q will tend to x coordinate of P. The points are closer means their x coordinate will be nearly equal, and that is C plus H will tend to C. C plus H tends to C. That is, when C plus H becomes equal to C, H will tend to 0. That is, H tends to 0. So this is the corresponding thing. That means as Q tends to P, H tends to 0. So taking limit on both sides of 1. So therefore from 1 we can write, from 1 we have, I shall take the limit here as Q tends to P for the chord. Limit Q tends to P, slope of chord PQ. And on the right side, I shall take limit H tends to 0, because it is the same thing happens at the time. Q tends to P, then H tends to 0. As q becomes closer to p, c plus h becomes closer to c, means h becomes closer to 0. And limit of this f of c plus h minus f of c divided by h. So this we have obtained. Now, but you see, what is the limit q tends to p? Slope of chord. This chord pq, when q tends to p, becomes tangent at p. So therefore, this is slope of tangent, and thus that is, I shall write here. This is, or we have written this, so I will write directly now. Slope of tangent. This is slope of tangent, because the chord PQ, when Q tends to P, becomes tangent PT. So this chord becomes tangent, slope of tangent at P. So, or we can write slope of tangent PT is equal to, and what is this? Limit h tends to 0, f of c plus h minus f of c divided by h. This is the definition of derivative, f dash of c, and this is equal to f dash of c. And thus f dash c represents slope of tangent at p. And also, but what is the slope of tangent? Pt, that is tan of the angle xtp, or if we denote this angle by psi, that is, if angle xtp is equal to psi, then tan psi, tangent of inclination, this is inclination of the line, and tangent of inclination is the slope. So tangent of psi is slope of tangent, tangent pt, and this is equal to f dash of c. So this is what we wanted to prove. Slope of tangent is f dash c, and that is tangent of the angle made by tangent line with the x-axis, and thus f dash c represents slope of tangent. So thus f dash of c represents or is the slope of tangent to the curve. What is the curve? We have y is equal to fx, and but at which point? At p, this point x is equal to c, and what is y? Y will be f of c at point c, f of c, and this proves the theorem. So this completes the proof of geometrical interpretation. This proves the theorem. So we have proved that, or we have seen what geometrical meaning of derivative. Geometrically, the derivative represents slope of tangent at the point where the derivative is taken, f dash at c. And this slope of tangent is also known as gradient. So this is about the geometrical interpretation of derivative, and remaining part we will discuss next time. Thank you.